Welcome, everybody. My name is Carlos Martinez, and I am Head of Safety and Health at Worksteel. It is my pleasure to be your host during this fourth webinar in a series that we created in collaboration with 3M. So far in this series, we have covered three very important topics: the fundamentals for working at heights using mobile elevating work platforms or MUPs, and working at heights during planned repairs and upgrades. If you missed any of these webinars, remember that you can access the recordings at worksteel.org or visit Steel University webpage. The scenario for today's webinar is working at heights on cranes and gantries. It is my pleasure to introduce Stephen Morris, our guest expert for today's session. During his 40-year career spanning many industries and sectors, including telecoms, wind energy, and construction, Stephen has gained extensive experience within many aspects of the fall protection and confined spaces access industry. Starting his working career as a telecoms rigger, he progressed into the height safety and confined space access training and took the role of 3M safety training manager in 2010. His current role as application engineer for 3M UK and Ireland provides him with an opportunity to support customers on all technical aspects of these challenging arenas. Without further ado, Stephen, welcome.
Thank you. Thank you very much, Carlos, and thank you again to Worksteel for giving us 3M this opportunity to present to you this morning or this afternoon. Okay, so as Carlos saying, that today we're going to look at accessing cranes. Before we start, just a quick disclaimer. Obviously, this presentation provides an overview of fall protection information and includes various 3M safety solutions. The webinar content should not be relied on to make specific fall protection equipment selections, use or maintenance choices. Also, local country and regional regulations and guidance varies, and the responsibility for the correct implementation of the fall protection program in compliance with your local country or regional regulations is with the employer. This presentation should not be relied on in isolation, as the content is accompanied by additional and/or clarifying information. Thank you. So, in this session, what we're going to look at is we're going to set the scene, first of all, and then look at the different types of plant and equipment we're talking about today. We're going to look at different types of cranes. And then we'll have a recap on what we've done in previous sessions, looking at the fall protection planning. We'll look at primary considerations, and then separating the task from the day-to-day work. And then to finish off, we'll look at some scenarios which are applicable to hopefully your work areas and look at some key considerations. And then we'll finish off with an example. So, setting the scene, cranes present several different work at height challenges that need to be overcome. Very often very different from each other and requiring independent solutions for training. For example, it could be vertical access, horizontal access, stationary or single point anchors, and also rescue and evacuation. And we need to consider all these options when looking at our typical types of crane. And within the industry that we're generally talking about gantry cranes, predominantly gantry cranes, but also there may be some sort of tower cranes as well. So what we're going to do in this session is look at both types of cranes and look at several scenarios regarding this type of equipment. Okay, but before we start, we're going to do a recap on some of the fundamentals of putting a work at height plan in place and what we need to consider. I appreciate we've covered this on previous webinars, but this will be a recap for those who missed the previous webinars. So when we talk at working at height, obviously there's a hierarchy of controls, and the exact hierarchy will obviously differ from region to region and country to country, but generally it's it's the same sort of system globally. So first of all, we ask ourselves, can we avoid working at height? Do we actually need to be there to do that task? We increasing now on cranes and things, we're seeing remote monitoring, we're seeing cameras and things like that, which can take a lot of the work at height away. Of course, it doesn't do away with all the work at height, so we still need to go up there. So next thing is, can we do it from existing workplace? Can we do it from a safe place of work? Or can we create a safe place of work? Can we use collective fall prevention equipment, which is things like guardrail systems, scaffolds, or MUPs, as we covered in a previous webinar? If we can't do that, then can we prevent falls using PPE? And this is generally what we call work restraint. So the worker is attached to an anchor point using a restraint system which prevents the fall. As we move down the hierarchy, then we start introducing things like fall arrest, where we're not actually stopping the fall from happening, but we're minimizing the consequence of that fall. So we're reducing the distance that you fall and also reducing those the forces that come into play. And we can do that collectively, so they can use nets and soft landing systems, or we can use it using personal fall protection equipment. Obviously, the last control there is minimize the consequences through training and instruction. So how do we put a plan together? What do we need to consider? First of all is why. Why is access required? Is it routine maintenance? Is it reactive maintenance? Is it really necessary? The next thing we consider is really what needs to be done. What tasks need to be carried out? What does the task involve? How many people will be involved? What equipment and processes will be involved? And what PPE as well? Then we've got to think about when. When are we doing this? How long will the job take? How often is it undertaken? What time of year? All these will be considerations when putting the plan together. We've got to think about where it is. Okay, what's the location? What hazards are presented by this location, and what are the existing controls in place? And finally, we need to consider who is actually undertaking this work. So everybody who's actually involved in the job needs to be competent at the appropriate level. And that includes not only the people undertaking the work, but the people managing the work, the people planning the work, and the people overseeing the work as well. So they're the main things we need to consider when planning work at height. Generally, this is done by creating a safe system of work, and safe system of work includes doing a risk assessment and method statement, often referred to as RAMs. And what this will contain is identifying the hazards, and this will be both hazards which exist and also hazards which we create actually doing the job. So if we're, for example, cutting or welding or using chemicals, then we're introducing a hazard. So we need to identify that. We need to think about who is at harm. And it's not just the people undertaking the work, especially when we work at height, as we'll see later, there'll be people working below us, people working around us. So what do we need to do to protect these people as well? We've got to evaluate the risks and identify the right control conditions. So once we've identified the hazards, then we evaluate the risk associated with that hazard, and then we implement or identify appropriate controls. Of course, all this needs recording. We need to actually make this available to everybody who's involved with that task, the people doing the work, the people supervising the work, and the people planning the work. And then, of course, we've got to monitor it and review it. So making sure that the work method is kept to, and then any changes that come in place are reflected in the risk assessment. When we think about the people undertaking the work, they've got to be competent. Competence is basically the safe application of knowledge and skills into the work environment. And competence is usually sort of regarded as a combination of skills, knowledge, aptitude, training, and experience all coming together. Competence is required at every level. It's not just the person undertaking the work, but competence is required by the managers managing the work, the planners, the supervisors, and of course those undertaking the work as well. Where skills aren't regularly practiced, and this is a proven fact, skill fade can be both rapid and significant. So it's make sure that as well as the initial training, is that those skills are practiced and maintained, particularly in things like rescue, where we hope we're not doing rescues very often or at all. So we need to practice those procedures to make sure that our skill level is maintained. The equipment we use, personal fall protection equipment in Europe is regarded as category 3 PPE. And because of that, we need to have a periodic inspection to make sure it remains in safe condition. And that needs to be recorded, and it needs to be done by a competent person. Of course, as well as that, then the user has a responsibility to check the equipment before use. And that's that capability should be covered in the training and instructions provided with that equipment. And then we implement the plan. So that's all about communicating our safe system work, communicating our risk assessment, our method statement, so everybody understands it. Everybody is aware of their responsibilities. Any other actions required are put in place, and also monitoring to make sure that the job is carried out as planned. If something changes, then we may have to review the process. So if a condition changes which has a detrimental impact on the task, then we need to stop, we need to reassess, and we need to implement additional controls identified and amend the working practice. If we're talking about generic risk assessments and things like that, then there's a responsibility there to put a periodic review in there just to make sure that conditions or known conditions haven't changed and they are up to date and still applicable. Okay, so what are our primary considerations? When we talk about personal fall protector equipment, before selecting personal fall protector equipment, we need to consider where that comes in the hierarchy and all the controls above it. So can we avoid it? Can we create a safe place of work using collective fall prevention and things like that? Having said that, PPE, personal fall protection equipment, does have its place in working at height, does have a very important place in working at height, and that can be used in combination with existing controls or in isolation. For example, if we've got a guardrail system, then at some point we've got to set that guardrail system up, and obviously that would require the person working at that edge using personal fall protector equipment. One other example, as we saw in previous webinars, is in MUPEs, in beam type MUPEs, where PPE complements the existing controls of the MUPE. It's important that we separate the task. Obviously, in a factory environment, foundries, metalworking facilities, things like that, it's a very, very busy environment. And there's lots of activities going on in the same area. When we're producing our safe system of work, we've got to consider other people who may be affected by our actions. So this may be setting out exclusion zones. It may be setting out controls to stop objects being dropped. It may be managing the workload or the activities in that factory so that two different activities don't have a detrimental effect. The other thing to think of, if there's systems or services which will affect the work that's being undertaken, then we may need to make, or we probably have to have those made safe. And they need to be made safe by a competent person. And commonly this is done under the permit to work system, where a competent person would isolate a system, make sure it's safe, and then they'd write the permit. That will probably involve lockout, tagout systems and things like that. And then they'll hand the signed permit over to the person undertaking the work, who will then acknowledge it with a signature, and then they'll retain possession of that permit while they undertake the work. And that's their sort of receipt, if you like, that the systems have been made safe. So work involving other systems usually works around a permit to work system. Okay, so let's look at now in some more details of some scenarios and solutions when we're looking at working at height on cranes. Now, we're all familiar with the ABCs. The ABC is a well-known sort of acronym really for how we describe a personal fall protection system. And it is a system. It's not just about wearing a harness. A harness in isolation doesn't protect you at all. It just means that you can fall wearing a harness. It's a system. And the basic system is ABC. So what we require for our fundamental system is A, an anchor point, B, a body support, and C is an element to connect A and B together. So a lanyard or something like that, which connects the anchor point to the body harness. And that's our basic fall protection system. Other considerations, D, E, and F, is descent and rescue. It's a requirement in Europe under the Temporary Works Directive that when we're looking at work at height, then we have a legal obligation to plan for rescue. What if something does go wrong? How do we get that person down? We can't rely on emergency services. We need to make those plans and have those provisions in place. We talked about education, the need to be competent. And again, only to sort of reinforce that we need to practice those skills as well. Make sure the skill level of those practices is maintained. And then the last one there, F, is protection of people around us, stopping objects dropping, hitting other people. So one of the main sort of considerations when working on cranes is access. How do we get to the all the parts of the crane? And depending on the crane type, this could be by a lift, it could be by a staircase or inclined stairs, but often we're using hoop ladders and fixed ladders. These are often used because of the restricted space on or around the crane, also the cost as well. So there's several considerations when considering these fixed ladders and these hoop ladders. Depending on your region and the legislation in your country, there'll be a maximum height of which a fixed ladder can be. In the European regulations, you cannot have a vertical ladder higher than 10 meters without a rest platform. If it is higher than 10 meters, then we need to install a rest platform every 6 meters. Obviously, climbing a ladder is very physical activity. It introduces fatigue, and what we want to make sure is that people aren't climbing or on a ladder exhausted, and obviously that is then going to put them in a situation of danger. Industry standard also tends to dictate that hoops or guarding systems around the ladder is a minimum. There's a lot of research done in this, and in the UK, the HSE has done a lot of research about the effectiveness of these hooped ladder systems, and basically work by entanglement. If somebody falls off the ladder, the assumption is that they'll fall backwards, and as they fall, their limbs will be caught into the cage of the ladder. So it's a pretty sort of crude method of stopping somebody falling down a ladder. There's been some tests done, and the conclusion really is that they are quite ineffective. And indeed, in the UK, they've made some recommendations about that every hooped vertical ladder is carefully risk assessed. They do have their place, but it's not the most effective way of preventing a fall or making sure people don't get injured. So what do we need to do? Obviously, as we said before, we introduce REST platforms, and the actual distance between the REST platforms and the spacing between the REST platforms, again, is very sort of regionalized depending on the legislation which we're following. Another sort of careful consideration is that if we're implementing secondary or other fall protection systems, for example, as we see in a minute, vertical fall arrest systems or self-retracting lifelines or something like that, we need to carefully consider how they perform in association with a hoop ladder. Because a hoop ladder puts restrictions on the way the people fall, it can have a negative effect on the performance of other systems. So again, in the UK here, the HSE recommend that the manufacturer should, or the customer should check with the manufacturer that the systems that they're proposing work together. And of course, if we are installing systems on a ladder, we've got to make sure that the ladder is strong enough for that purpose. Because if we put a fall arrest system on a ladder, in a fall, obviously that's subjected to a greater force than the person's weight climbing the ladder. So we need to make sure that the ladder is suitable for the system that we're installing. And here's some examples of how we can provide personal safety or personal fall protection equipment for accessing a vertical ladder. And there's several options available, really. On the left here, we see a self-retracting personal lifeline system. So these work on the same principle as car seat belts. They retract and extend, and the method of climbing a ladder using either traditional lanyards or these lanyards is that you obviously maintain 100% connection at all times. So at least one of these hooks is connected to the ladder rung at any one time. It takes a bit of practice. It is slow. It can be quite tiring, but it can provide a safe means of ascending a ladder. Obviously, in a fall situation, as we see a bit later, you are going to fall a distance before this equipment becomes effective. So we need to make sure that this method of accessing a ladder is applicable to things like the height of the ladder and the equipment around it. Another solution is using a self-retracting lifeline. And these work on the same principle as the personal self-retracting lanyards. But this is a much bigger unit, which is anchored above the ladder. And there's lots and lots of different types of unit available, different lengths. They can be steel wire lifelines, or they can be webbing type lifelines. And the idea of these is obviously they retract as you climb up the ladder, but if you slipped or fell off the ladder, they're speed activated. So at a given speed, the spool, which is holding the lifeline, locks and arrests the fall. They'll also have a shock absorber built in there as well, because you're introducing a shock, a peak loading, if you like, when you arrest the fall, which can be fatal. It can be very high. We need to put a shock absorber in there. So the shock absorber can actually be on the lifeline itself, or it can be integrated into the unit. Now, this particular unit here that we see in the center, this is what we call an RSQ, and this is a self-retracting lifeline, but it also has in a automated rescue system. So in the event of a fall, then the block has two functions. It can either lock off and then be released and lower the person down under control, or it can do that automatically. So it'll lock off and then instantly release and lower the person down. So with this type of equipment, we've ticked two boxes. We've ticked the fall protection box, and we've ticked the rescue as well. The third system on the right there, that is a fixed fall arrest system. So this is something which is installed onto the ladder itself. As we said before, we're going to make sure that the ladder is suitable and strong enough, because in a fall situation, as I said before, you're going to generate a lot of force. That will be restricted down to 6 kilonewtons or 600 kilograms force, thereabouts, by the shock absorber on the system, but it's still over half a ton of force on the ladder. So we need to make sure the ladder is suitable for this installation. So this system here is the cab lock system. There's other systems available, and it can be mounted either in the center of the ladder, we've seen there on the rungs, or on the side of the ladder. And then the user just has a small shuttle trolley there, which attaches onto the wire and then runs up the wire as he climbs up. In the event of a fall, it locks off, stopping the fall very quickly. So these are, again, a really effective way of fall prevention on a ladder. But just to reinforce what we said before, if we're using these systems, then we need to do those checks, those risk assessments, that they do work within the type of ladder we've had. So if we've got a hoop ladder, we've got to make sure that the system is compatible with use within a hoop ladder. Okay, so let's look now at a common task. One of the most common type of crane that we're going to come across at a foundry and a manufacturing plant is the gantry type crane. And we need to very often access the gantry itself to do tasks like maintenance, routine maintenance, reactive maintenance, maybe modifications, fitting, things like that. So sometimes these platforms have guardrails. So at the bottom left there, we can see a guarded platform. The walkway on there has a permanent guarding system. We may have single point anchors. So in the center there, we've got a fabricated anchor post. That's got a straight lanyard on there. And that's for one particular work position. So if there's a work position where we need to carry out a task periodically, then we may use a single point anchor. Because they're obviously limited to the area or the work area, if we have to move along the gantry, and obviously some of these gantries can be 20, 30 more meters in length, then a running system or a wire or rail system would be a good system. So on the bottom right there, we see an access platform, and it has a foot level tensioned wire system, an 8mm, that's a Sala system, and the worker will connect onto that line using that shuttle which you can see on there, and that will travel the length of the wire. So that will protect him all the way along that platform. So on that platform there, they've got 2 levels of protection. They've got obviously the guardrail, but what they have to do sometimes is actually lean or work through that guardrail. So they've also got a horizontal lifeline system installed on the platform as well. So those are all sort of typical fall prevention anchor points which we can implement onto a gantry type crane. Some of the hazards which we need to consider. Obviously, there's the open edges. Also, that some of these open edges can be quite sharp. If we're thinking of, we could fall over a toe board or a sheet steel, plate steel foot plate, then that's quite a sharp edge. And if we did fall over that edge, then that could cut a standard lanyard or even a steel fall arrest wire. So another consideration is what we call edge equipment or edge-rated equipment. And this edge-rated equipment is, again, lanyards and self-retracting lifelines, which go under additional level of testing to make sure you can withstand falls over sharp edges. We're going to consider as well moving equipment, winches, trolleys, things like that. Obviously, if possible, we always want to isolate the crane, but sometimes in fault finding, then we need to have the crane in a position where, or in a state where it can be moved. And the same goes for live buzz bars and things like that. Again, if we can, we'd always isolate the power and isolate the equipment, but sometimes that's not always possible where we're fault finding or whatever. So we need to be aware of that. That's hazards we need to address on our risk assessment. We need to think as what below us. Obviously in a foundry, we've got a lot of hot works. We've got moving plants. We've got things being moved around. We've got vehicles, things like that. So we need to be aware of what's below us as well. Another consideration is, obviously, as we said before, the length of these crane gantries can be quite a long distance. So it's single point anchors and move between single point anchors would be very tiresome and not very practical. So we're really looking at continual attachment systems. So that, again, could be a tensioned wire system, a horizontal lifeline system. It could be a temporary one, permanent one, or it could be a rail system. A rigid rail system. Another consideration is the environment which you're working in. Obviously, foundries, metal fabrication facilities, things like that, are by very nature, they're very hot, they're very dusty atmospheres. Obviously, heat travels upwards, and it's usually in the upper part of the building where we're doing this work. So it can be very hot, it can be very dusty. Some of the processes use chemicals and things like that, which are not particularly healthy to us or may present a health hazard. We need to be aware of that as well. The final thing on there is dropped objects. Again, as I said at the beginning, we've got an obligation to not only protect the people working at height, but also those who are affected by their action, those people at ground level, those people who are working below us. So there's a number of controls you can put in place. Obviously, as we saw before, exclusion zones, hard hat areas, signage, things like that. But if we can stop the equipment and the tools dropping in the first place, if we can tether that equipment, that's a good control. So let's look at one of the solutions I've mentioned several times now, which is this is our 3M 8mm permanent horizontal lifeline system. And what it is, it's a series of components, and there's the main components there. The other component not shown there is obviously the 8mm stainless steel wire. And using these components, we can design and configure and install the system suitable for just about any walkway, any crane, any platform. So we can put bends in there. We can use different type of anchors. It can be in different positions. It can be at foot level. It can be at waist level. It can be overhead. There's lots and lots of different combinations. And what we've got next is a short video that just shows you how all these components can come together to make a system. And what we do with these components, we sell these through authorized installers who will then design the system and install the system. So hopefully now this video will work and it will show you how the system works. Okay. As you can see there, it's kind of straightforward system. That's our 8mm cable system. You may have noticed underneath that was a solid rail system as well, which is our rail system, and it works very much the same way, but it uses a solid rail in sections, and it's got preset bends and things like that. Also, you may have noticed on the sorry, start again there. Another thing you may have mentioned, sort of noticed on that video, was that at the anchor points, it had these devices here, which is the energy absorbing unit. And these units here are not to lessen the force on the person in a fall. They're not, if you like, shock absorbing for fall arrest. They're energy absorbers to protect the system, because with a tensioned cable system, obviously a fall on that system is going to create high level loading at the anchor points, and this loading on the anchor points can be in excess of 2 tons. So what we do to protect the anchor points and protect the system is put any energy absorbers on the end anchors, and this is one of our innovations, and this video here shows you how these end anchors, or these energy absorbers at the end anchors, work to protect the system in a fall situation. You can see there's the forces applied. The red spring there, that's there really to hold the tension in the system, to compensate for things like temperature differentiation and things like that, and keep the correct tension on the system in normal use. But in a fall situation, you can see how those perforated strips are designed so they rip apart, and they rip progressively, absorbing the force and reducing the force on the end anchor points on the system. We talked about the position of the system, and this is very important. So ideally, if we can put the system in and use it as a restraint system, and the restraint system means that we use a lanyard from the system as a length that we can get to the work position, we can undertake the task. But if we slip, trip, fall, or whatever, we cannot fall over that edge, so it stops the fall from happening. If we're using it for fall arrest, the best position for the system is overhead, because if it's overhead, then the fall distance, the free fall distance, is going to be minimized, and we can arrest the fall very quickly. In some situations, this isn't possible, so we may have to put a fall arrest system at foot level, but we've got to accept there that we're going to fall a greater distance, because what will happen now, we'll fall the length of the lanyard. And this is what we call fall factors, and it's shown here in this diagram here. So starting at the left-hand side there, this is what we'd commonly sort of call fall factor 0. So it'd be the anchor point directly overhead and the lifeline in or fairly taut. And in a fall situation, the free fall distance will be minimized. As the lanyard gets longer, or the anchor point lower, then we're introducing more free fall. So the fall factor, which is the ratio between the distance that we fall and the length of the lanyard, is increased. Once the anchor point and the attachment point and the harness are at the same level, then obviously what we're going to do, for example, here in the third example, what we're going to do is fall the distance of the lanyard, or we're going to free fall the distance of the lanyard. So this is regarded as fall factor 1. So 1 refers to we're going to fall the full length of the lanyard. As the anchor point moves down to foot level, then we're going to fall further than the length of the lanyard. The worst case scenario is we fall twice the length of the lanyard. So we're standing up above the anchor point, So we fall the distance to the anchor point, and then we fall from the anchor point down to the length of the lanyard. So this is what we call four factor 2 commonly. And we've got to consider how much fall clearance we've got below us. So you can see in all these scenarios, as the anchor point moves down, or the fall factor increases, then our fall clearance or our required fall clearance increases. And the last option there, you can see that although we have a fall protection system, it's ineffective in that the person could hit the ground. Another consideration is that, as we said before, a tensioned wire under load will deviate. So there'll be natural stretch in the wire, and also we've got those energy absorbers which will extend the length of the wire. So we've also got to consider what we call cable deflection and the increased fall clearance which that will incur. Now, this is quite a complicated calculation, so that's why we go through a process or a system of qualified installers who plan the system. We've got planning software which calculates all the fall distances required. That's dependent on things like span length, number of users, things like that, and how often we put the intermediates. And that will have an influence on the deflection and effectively the fall clearance required for the system. What we've also got to consider, if we're using fall arrest systems, for example, a self-retracting lifeline on the system, is that, or a lanyard, that will also have a length, and it also have shock absorbency built in. So worst case scenario is using something like a 2-meter fall arrest lanyard, that if we fell, we could fall the 2 meters of the lanyard, then the shock absorber deploys, and the shock absorbers can be 1.75 meters long to slow the person down. Then you've got your body length, which in this calculation we use 2 meters, and then we've got a safety margin. So you can see once we start adding all those figures up, we're up to about 6.75 meters. And if you think of a lot of the workplaces, you may not have that 6 or 6.75 meters fall clearance to the surface below. So selecting the right equipment is important. So what about maintenance access? You can see here some of the challenges that we've got. Sometimes this will require access to places which haven't got fall protection provided. So this could be inspection work, it could be maintenance, it could be repair, it could be replacing cables, things like that. In these situations, obviously, we need very careful planning. We need to consider how we actually get to these points, how we work safely at these points, and making sure that we can do this safely. So there's a lot of considerations when doing maintenance on gantry type cranes. And again, things like falls over edges, what is the existing fall prevention? Is there any? Moving parts, winches, motors, pressurized systems. Again, what's below us? How difficult is the access? As you can see on that top example there, the actual trolley is very close to the roof structure. So there's entrapment dangers, things like that. And again, as we had before, we've got atmospheric conditions, dust, heat, and again, dropped objects. And again, sometimes we will see on that bottom right picture there, they're not always the cleanest places to work. So we could have trip hazards, slip hazards, things like that. So it's important that we correctly risk assess this work and make sure we've got the right controls in place. So let's look at some of the controls we've got for PPE, personal fall protection equipment. Obviously, anchor points is important. So we have things like beam clamps. These designed, as the picture shows there, to clamp onto a either a horizontal or a vertical beam. We do 2 types. This is the fixed anchor, which clamps tight onto the beam. We also do a sliding beam anchor, which will slide along the beam behind the user. Our traditional slings, which is wrapped around part of the structure. Obviously, both these, the beam anchor and the sling, we've got to make sure where we're attaching this is of appropriate strength. because in a fall situation, as I said before, we can be putting a force of around 6 kilonewtons or 600 kilograms force onto that structure. So there's lots of different types of anchor straps available. Very often we're using these reinforced ones. Obviously, this is an incredibly strong webbing sling, but it is susceptible to cutting on sharp edges. So you may want to consider things like steel wire slings or protected slings like we have here. Well, the other option is a fixed anchor point. Where we're installing a fixed anchor point, typically where we've got routine maintenance to be done, we're often carrying out tasks in that position. So we may want to put an anchor point from which to work, and it could be restraint or fall arrest. Obviously, we don't take that out. We don't take us with it, so it's not PPE, but it is required to have a statutory inspection usually every 12 months in this case. And then we've got to connect, obviously, to the harness. So we need some means of connecting. And again, there's lots of different ways of making that connection. So starting on the left here, this is an adjustable restraint lanyard. So a restraint lanyard doesn't have a shock absorber in there because we're not going to fall on it. The whole idea is that we stop the fall from happening. So this one's an adjustable one. We connect onto the anchor point here, we connect onto the harness, and using this device here, we can adjust the length of this lanyard so we can reach the workplace, but we physically cannot fall. Next along, we have traditional fall arrest lanyards. They can be single leg or twin leg, can be webbing or rope, different connectors on the end. But the important thing now is we've got a shock absorber on there, because this is a device which can or is designed to take a fall. And again, because of those peak forces which can be damaging, we've got a shock absorber in these units. And again, we can get edge-rated systems. So these systems are tested over a 0.5 millimeter radius. So they're, if you like, anti-cut equipment. We have self-retracting lifelines, or SRL. And these, again, come in different sizes, different lengths, different types of lifeline. And in a fall, they lock off at a given speed, and then they'll have some form of shock absorber in there to absorb the force. It could be external, like on this one, or it could be built into the casing here. The smaller version of these, personal self-retracting lifelines, these are designed for mounting on the harness. So these are mounted on the harness, usually about 2 meters up to 2.4 meters. And again, we do an edge-rated one for working near sharp edges. So it's all about selecting the right equipment for the right situation. Another consideration is, obviously, if we get to the workplace and we need 2 hands, so if we're working off the ladder or working on the structure, we always need a primary and secondary means of stopping the fall from happening. So usually on a ladder or on a structure, our 3 points of contact is our primary means of attachment, or and we'd use a lanyard or a self-retracting lifeline or a guarding system as a secondary. Where we have to work off a ladder or work off the structure and be supported and use both hands, obviously we're compromising our primary means of attachment. So often we can use what we call a work positioning system. So here we have a belted harness with additional attachment points on. We have this lanyard around the structure, which allows this person here to work with both hands free. So this effectively is his 3rd point of contact. Now, it's still a primary means of attachment, so we also need his secondary means of attachment here, which is his fall arrest lanyard. So typically your PPE there would be a belted harness, and we can see the additional waist belt and the attachment points here, a adjustable work restraint lanyard, the same as a work positioning lanyard, and a fall arrest component as well. Could be lanyards, it could be a self-retracting lifeline. We need to consider rescue. Now, we are doing another webinar on rescue, so I'm not going to any great details here, But as I said before, we've got a legal obligation to consider rescue when working at height. So it's a case of putting a rescue plan together. And that could be using, if we've got MUPs on site, using MUPs, use scaffolds, or it could be using dedicated rescue equipment. Now, you've probably all heard of suspension intolerance, which is a physical condition brought about by being suspended in a harness. And what we do with a lot of our harnesses is put these suspension straps on here, which you can step into, and it relieves some of the tension on the body, on the person, while the rescue is prepared. And again, rescue options include, we saw this before, what we call rigged for rescue, automatic rescue systems, or we can have dedicated rescue kits like we have here, which can be deployed to get somebody down. So we're using this equipment, we can lift people up and we can lower people down. It's also self-lowering as well, so it'll lower the person at a given rate. So we can use it for evacuation as well. And evacuation is important where we're talking about tower cranes and gantry cranes and things like that. Because usually there's one means of access here, there's one direction of access. And if that access is compromised, then we may need to get down there quickly. So we may need the operator of this crane to get down from that cab in a different way from the standard access. So again, we have different types of evacuation equipment which connect into a dedicated eye bolt, usually in the cabin, and then the person can lower themselves down to safety, or the equipment will lower them down to safety. One of the last things to look at really is dropped objects. We talked about the need to protect those below us. Again, there's a full range of equipment to tether equipment back to either ourselves, if it's lightweight equipment, we're talking about sort of 2.5 kilograms, something like that, or back to the structure, if we're talking about heavy equipment like the Bocher machine here or the impact wrench. So it is basically ABC again. We're connecting back to an anchor point. It could be ourselves, it could be the structure. We're connecting onto the tool, which is basically like the body harness, and we've got a connecting element between. And all this equipment has different weight ratings depending on what the tool is, and we've got lots of different ways of connecting different tools to the lanyards. Also carrying equipment, lifting equipment, things like that. We need to make sure that we don't drop equipment during lifting operations or carrying things around. Even small nuts and bolts can cause a lot of damage falling from height. So we're getting to the end now of our presentation. Of course, all these resources are available on the dedicated website. So we've got the Steel University set up from the World Steel Association, and members are given access to this. On here, you'll find a full range of courses using 3D modeling, very intuitive the way that they work. They're really, really good, giving a really good understanding of different aspects of working at height. So this has been developed over some time, and it's a really, really good resource. So have a look at that. So just to recap then, we looked at setting the scene, what we're looking at, the types of cranes. We did a recap of fall protection planning, what we must consider when putting a fall protection safe system work in place. We looked at primary considerations. We looked at the need of separating the task from the working environment, making sure we don't endanger other people when doing the task. And then we looked at some example scenarios, some solutions, and some key considerations. And then obviously we finished off just looking at the resources available. So that's the end of the presentation. Again, it's one of a series of presentations that we're doing. So hopefully you found that information useful. Don't forget, there's a lot more information on the Steel University website. And I open up for any questions. So either type them into the comments or unmute and shout out, and be happy to answer any questions we have.
Thank you, Stephen, for this great presentation. Yes, I think we do have some questions,
Okay.
so I will pass them on to you. So the first one is, if a person falls using the this kind of systems, for example, I think this question came when you were talking about the horizontal lifeline.
Mm.
Does the entire assembly need to be replaced?
Yeah. Obviously, during a fall, we have very high peak forces, and the system is basically designed to be sacrificial. So everything within that system, right from the harness, the connecting lanyard onto the system, and the system itself, would need, well, definitely the harness and the lanyard would be basically replaced. That would be scrap. The system itself would be re-inspected, and obviously a lot of the elements on there would need replacing. So, for example, the energy absorbers at the ends there would need replacing because they will have deployed. Wire would probably be damaged at some point, well, not damaged, but it show the effects of the fall. So that would be replaced. So the system, we may not have to replace every element on the system, but it would obviously need obviously the installer or the inspector to come back out, inspect the system, replace all the necessary components.
Okay. So there were a few questions related to the same thing. So and it's basically the examples that you were given at the end about how to rescue an operator in case yeah, the means of access cannot be the same that normally the operator would use,
Yeah.
or this kind of situations.
Yeah. With your rescue plan, as you're putting your rescue plan together, what you've got to consider is all the foreseeable situations. So that includes things, for example, the faults with the equipment, if something gets stuck, if you have to evacuate, but also, medical health. It's not unknown for people to have medical conditions. So if you think of somebody up on a platform or even in the cab there, and we need to get them down, then we need to develop a rescue plan which meets those requirements. And what I always say with rescue plans is keep them simple as possible. If we've got MUPs available, let's use a MUP. If we've got scaffolds, we can use scaffold, or a suitable platform. Again, there are lots of systems that we can use, rescue systems, which we can use to keep people down. So in this example here, obviously we've got this is the R550, and this is specifically designed to be a self-contained rescue unit. So we attach the end to the casualty, we can lift them up, we can disconnect them from the system they've fallen on, and then the system itself will lower them down. The same with evacuation. If we use an evacuation, it's exactly the same piece of equipment, really. We can rig it to a suitable anchor point. The operator can then connect onto the system. Obviously, you need a harness. Very often they use a dedicated rescue harness, which is just like a wraparound. They call them nappy harnesses. They'll connect in the system into his harness, and then the system will lower him down, and it lowers them down, around about walking pace of 1.5 meters per second. So the systems are out there to do it. It's a case of really just doing that rescue assessment, looking what the foreseeable situations are, and how we can put an effective rescue plan into place. The real danger is when people are suspended in their harness. And again, we're going to do this in a future webinar, but being suspended in a harness, then really you've got a very short time window to get that person down. So something like our R550 equipment here, and a appropriately trained person can rescue somebody else very quickly using this equipment. Again, if you need any more details, then Carlos, I'm sure you can reach out to ourselves, and we'll be glad to provide more information.
Yes, definitely. Well, thank you, Stephen. I think we are right on time.
Okay.
I appreciate your presentation. Let's give people the opportunity to know the answers of their questions later. So I will pass them on to you, and then we can answer them via email. Of course, there are more questions related to different topics, and yes, we will be covering things like roof work, rescue, evacuation in other webinars. So yeah, remember that you can find all the information at worksteel.org or through the C University webpage. Thank you, everybody. Thank you, Stephen, again, and see you next time.
Thank you all.